Okay, we continue rather, our revision paper 1. Remember, this session is to remind us quickly and to fill any gap we have. Okay, this we did, and we did this. Inequality as well, very important. Simultaneous equation. All right, now I came across a few questions, and I thought I should just add it to the pool of questions that we're dealing with, starting from this one. Number one, you need to be able to identify this as a quadratic equation. Okay? So you must identify this as a quadratic. And not just it's a trinomial, you can see it's 3 terms. However, do you see that it's a quadratic? That's where the question is. The first thing I'm going to tell you today is, for me to have a quadratic equation, I know that ax squared plus bx plus c. And this is how I see it quickly. Look at my highest exponent of x. If I were to divide that by 2, I'll get the next exponent, which is 1. And that's a very important point there. That ax squared, my highest exponent, is divided by 2. If I then divide that exponent by 2, I'm going to get the next exponent. And this is the reason why when you open a bracket, check this. This is the whole idea. You drop this here. It is the middle one that you drop. So that x times x would give you what? X squared, which is that. I don't know if you see the connection. So if you look at the middle term here, and you see that if you square that, you're going to get that, then you can start treating it like a quadratic. For example, look at what you have. X to the power 1 over 5. If I were to square that, what would I get? X to the power, we just multiply this lots of exponents. 2 over 5. And if you check, it means I am dealing with a quadratic equation there. So, now it depends on you how you want to approach this. You can use the K method, if you like. All right, so let me do this in 2 ways. I'm cleaning this because I need my space. Somebody would say, let K be equal to x to the power 1 over 5. That's your focus. Now, if you check, my 3x2 over 5 can be written as 3x 1 over 5 all squared. Because 1 over 5 squared is the same as was 2 over 5. Minus 5x minus 2. Now, if my k is equal to x to the power 1 over 5, I'm sure we see what to do here, right? What do we have? 3k squared minus 5k minus 2 equals to 0. From here, it depends on you. Do you want to use a calculator? Do you want to factorize? Do you want to use quadratic? All right. I know Bibi's already given up. She's running for the quadratic already. But let me try without a calculator. You know what we do? Do you? Do you remember? K squared minus 5k minus 6. Question is, where did I get my 6? Multiply my 3 and my 2. Can I factorize that? I think this is now easy to deal with. K. What will work here? Be careful with this 5 and 6. Because 2 and 3 would work. 6 and 1 would work. So be careful with the right combination. I need a negative 6. Definitely a 6 and 1 would be my approach. All right, and I need a negative there. So here we go. But remember what I did. I had multiplied by what? 3. So what do? Divide by 3. So this would give me k minus 2. And this is 3k plus 1. Okay. That's what I'm going to bring in here. 3k plus 1, k minus 2. So what do we have? 3k equals to negative 1 over 3. Or I can just, okay, let's say 3k plus 1 or but remember, we are not interested in k. We are interested in what? X, not k. Okay? So what do I then do? My k is x to the power 1 over 5 or equals to what? 2. What do we do? Now, this one is an odd number. Therefore, a negative is allowed. If it was an even number, we would not get a negative. Okay, so what do? We multiply both sides by what? Exponent of 5 to get rid of our 1 over 5. Negative 1 over 3. So whatever you do on the left, make sure you do on the right. Or x 1 over 5, again, to the power 5, 2 to the power 5. That whole thing would give you 1. This would give you negative 1 over 243. Or x equals to 32. So the reason I brought up this question is see the quadratic in a different form. So expect that. Once you see a fraction on top, just check quickly, is it a quadratic? And how do you check if it's quadratic? Highest exponent divided by 2. Check if you're going to get the next exponent. It's just a little secret that we need to know. Otherwise, the rest of the game is so easy. Okay. Done? Any question? Guys, are we good? Did this make sense? Just exposing us to fraction trinomials. Somebody else could have just, if you identify this trait, you could have just done this. X to the power 1 over 5 equals to minus, use your negative b, plus or minus square root of what? B squared minus 4ac. I wanted to check. I didn't say x. I said x to the power 1 over 5 because that is what I am using. That's what I'm solving for. All right? So if you do that, then you're also fine. Okay. I'm just passing by. I just passed by this question. I said, everything I see that is just strange, I'll bring your attention to it. And whatever you see as well, please feel free, let me know. I know some of you, I still owe you questions. Just, it's hectic as well. Okay? Next question. Again, this simultaneous looks a bit strange. All right? Looks a bit strange. What do we do here? We try to simplify. If I start from the left-hand side, what am I going to get? So look, in math, all you need to do is ask yourself, what is it that I can do? If I start from the left-hand side, what would you do? I would cross-multiply. Because the examiner has told you it is what? Simultaneous. So I will start from the left-hand side by cross-multiplying. You will do that as well. Lovely. So 2x will be equal to what? 1 plus y. Don't make your life complex. Don't look at fractions. 2x minus 1 equals to y. What would you then do? Sub into this equation. All right. Okay, we can sub in and we can do something else if you don't want to sub. Okay, you want a foil. You can. But I don't want a foil. I can just sub it in, but I just don't want to sub it in. So I should not do it. Okay, no, you can just sub it in and then deal with it. All right? Let's sub it in together. What are we going to have? 3x. Now, please take note. I just want to do something here. The reason I'm subbing this in because of that minus. When I did this the other day, I did sub in. But I want to sub in because of that minus. Please take note. Anytime you have a minus, open a bracket. All. So it's 3x minus y. So instead of just writing 2x minus 1, that is a problem. Are we together? So that's my y. You see, it's in a bracket. Please, let's take note of that bracket. Then what do we have? X. What is my y? 2x minus 1 equals to what? 0. I think we can simplify now. 3x minus 2x plus 1. What is x plus 2x? 3x minus 1 equals to what? 0. What is this? X plus 1. All right, please, again here, don't expand this bracket. Why? These things are already equal to what? 0. Don't waste time expanding. Just know that x plus 1 equals to 0. X equals to what? Negative 1. Or, and x equals to 1 over 3. What do? We throw it back into that equation. All right, so when x equals to negative 1, y equals to 2 into negative 1 minus 1. What will this give us? Negative 3, right? And then when x equals to 1 over 3, y equals to 2 into brackets. I know you can all do this. 2 over 3 minus 1. Negative 1 over 3. We can all do all of this. The main idea was how to interpret that first part. Nothing hectic. Right? Okay. Check this. I saw this question. Okay, I did this on Saturday with you guys. But guys, this question came as a question 1. And I just want us to do it. It's functions. F of x equals to g of x will have only one root. Nature of roots. And I brought this up because Leslie also asked me about nature of roots. What does root mean to you? Root means the point of intersection. Is that okay? So don't ever forget that. Root means a point of intersection. That's one of the meanings. Okay. Examiner says f of x equals to g of x. Look, let's equate. That's what you would have done. Lovely. 3 over x minus 2 equals to 3. How do you solve from here? Anybody? Suggestions? Runga? What would you do? BB? What would you? Those of you at home, I need a suggestion here. What would you do from here? Okay, I want to follow your step because I want to see your algebra here. I should, no, don't worry. I should take this x minus 2 over to the other side. And what would I have? Tell me what you're thinking. That's why we're here. I should cross multiply. Okay, wait. I should cross multiply, right? Remember, this is 3 to the power of x minus 2. So what would I have? What would you have? 3 would be equal to 3 into power of what? X minus 2 times 3 times x minus 2. Okay, I don't want, my times is looking like, what do we then do from here? Guys from home, I'm also waiting, please. Yes, Ritumeti, unmute. Okay. All right. So wait, this is BB's part. Let me create a part for you. You said I should do what? I should write. let me interpret what this means to you. If you write 3 to the power negative x minus 2. Let's go back to laws of exponent. Because I want us to see what we would have done in an exam, right? If I write 3 to the power negative x, what does this mean? It means 1 over 3 to the power x. So they are not the same. So if I were to change this, what this means is 1 over 3 to the power what? X minus 2. I see where you are going. You're trying to make this have a base of 3 so that you can equate the exponents. But the algebra interpretation of your exponents there is wrong. 3 to the power? Okay. No. Yes, I'm waiting. Fahima? Okay, Leslie says if we separate, Leslie, okay, I want us to explore. If we separate 3, this would give us 3 to the power x times 3 to the power negative 2, right? Using laws of exponents. All right, we are saying 3 over x minus 2 equals to 3 to the power x times 3 to the power negative 2. Yes. Leslie, this is what you're thinking in your mind. All right? Now, what would you do from here? Talk to me. Unmute yourself, guys, so that it's fast. Because I want us to see. Factor out where? Okay, Bibi, just 1 second. Just 1 second. Leslie, you're saying? Yeah. Okay, you don't know? Take the 3 over. Which one? 1 over 9. Okay, see. Let's see. So she says 3. I see what you're doing. Let's see. Look, I'm going to listen to you as long as, and if it's incorrect now, I start correcting. This is times 1 over 9. That's what you're saying, right? And if you divide both sides by 1 over 9, the 9 goes up, becomes what? 27 over x minus 2 equals to 3 to the power x. If we multiply across, you're going to have 27, all right, multiplied by what? X minus 2. Okay, wait. Bibi is saying something. I should multiply in. You cannot multiply in, guys. Okay, if you multiply, you're going to have 3 to the power x multiplied. No, it's fine. We're learning. Okay, I should change 27 to a factor of 3. Okay, so 3, all right. 3 cubed equals to what? 3 to the power x multiplied by x minus 2. Then what do we do from here? Bibi says we should put a blind eye here, that like it doesn't exist. Really? Okay. Any other person? Ritu said, it's like, I'm doomed. Guys, this is a very lovely question. And the fact that, I'm just trying to figure out what you guys would do in an exam. And you will have done all kinds of algebra here, right? No? Okay. Leslie, shoot. Why would I find the inverse, though? What would I be looking for? All right. No, it's okay. Just like you just, and you see, check, it's 3 marks. Okay. All right. Now, what I'm trying to show you that I see quickly that I am stuck here, algebraically. I promise you, even I don't. That's what she said. Why? There must be a reason for looking for the inverse. Why would you? If I look for the inverse of one, I must also look for the inverse of the other one. Because whatever you do on the left, you do on the right. Okay, so now let's do this. What do you notice about f of x? What type of function is this? What type of function? We are dancing Indian dances like this, like this. What type of function is this? It's a hyperbola. And I know that, can we sketch this hyperbola quickly? All right. To sketch this hyperbola, what are we going to have? Okay. Guys, quickly, walk with me here. To sketch this hyperbola, I know I need two asymptotes. What is my horizontal asymptote and what's my vertical asymptote? We're revising already. We're in functions already now. Beautiful. X equals to 2. So, no, there is a y asymptote. No, it's 0. No, you said there is no y asymptote. There is. Good. There is. It's not like there's not. There is. When you say there's no, the fact that y equals to 0 does not mean that it does not exist. Good. Y equals to 0. Now, that's my other word, asymptote. Make sense? Now, if I were to sketch this graph, you should know how to sketch without even calculating, guys. Yeah. That is A. You can find your intercept, remember? But we can sketch this without intercept. Now, your A is positive. That should tell you which quadrant you are drawing your graph in. This is what I do in case I get confused. I know that is positive. That is what? Positive, negative, and negative. Since my A is positive, which two signs do I multiply together to get positive? Positive and positive? Good. It automatically tells me where my graph is. Positive and positive, negative and negative. I am done with the sketch of f of x. Make sense? Now, let's look at g of x. What type of function would you say g of x is? It's an exponential because your x is an exponent. If you are not sure of what to do, you know what you can do there? You can find your x-intercept. All right? 3, or you can find your y-intercept, rather. 0 minus 2 would give us 1 over 9. Good. So it means that I have a positive what? Exponent, intercept, 1 over 9. By the way, do you know that this one also has an asymptote? It's plus q. But your asymptote is what? 0. Okay, so it means that works for both of them. Now, what is your 3 to the power x minus 2? It's an increasing function. Why is it increasing? Your x is positive. When you sketch the graph of 3 to the power x, your graph goes this way. When you sketch the graph of 3 to the power negative x, your graph goes this way. Negative tells you it is what? A decreasing function. Positive tells you it is an increasing. Let's sketch this graph. What are we going to have? Check this. What is this? G of x. How many points of intersection do you see? And that's your answer. Motivate your answer. You see, they're not telling you to find the number of intercepts. They said it will have only one root. Motivate your answer. A sketch would be very easy for you to do, and you are done. You don't need to write anything. Yes. Yes, good. They didn't say sketch. If it was possible for us to solve algebraically, we could have solved. But solving this algebraically needs some crazy maths. It's not vague. Okay, what are you saying, please, too? Okay, Alima, I should re-explain. All I did was to sketch graphs. So the first thing I noticed is my hyperbola, my f of x is a hyperbola, right? And all we did was to sketch that hyperbola. And to sketch, okay, to sketch a hyperbola, what do we need? We need our asymptotes. So f of x is equal to 3. I hope you can sketch. X equals to 2 would be my vertical asymptote. This is plus 0. And y equals to 0 would be the horizontal asymptote. And all we needed to do was just sketch that graph. I know the question is, why would you think of this in an exam? Because we have tried to solve algebraically and we were not winning. Okay, it's not something new, Leslie. It's just using, because if we could solve, I promise you, we would not be sketching. But once you see functions, let's learn to sketch. It's always easy to sketch. When it comes to functions, always sketch. It's easier to read from the graph than to solve algebraically. So there's f of x. All right, so we have x equals to 2 and y equals to 0 there. So we have our, Alima, I hope you can sketch a parabola or hyperbola. And then we have our exponential function. Again, I've told you right now again how to get your exponential function. What I did was, this again is 0. My horizontal asymptote. This one has no vertical asymptote. No vertical asymptote for exponential function. It only has one horizontal asymptote, y equals to 0. Now, what did we do? I looked for my intercept, just to make sure I get it right. Put in x as 0. We got 1/9. And because I didn't even need that actually, but just to show you. And because x is positive, it is an increasing function that is above my asymptote. So there we go. And they would only intersect at one point, which is a point of intersection, which is also called the roots. The reason why we're doing this graphically is because it was difficult to solve algebraically. So for this, 1 mark would have been for your sketch of f of x. 1 mark would have been for your graph of g of x, and 1 mark would have been, because they told us it has 1 point. We were just showing that they are correct. Interesting piece of question there. Okay. Yeah? Are we okay? Okay, let's quickly go to this. Nature of roots. For which values of p will the equation that, listen, if you want to pass this, you must understand the fundamental values of nature of roots. That roots can either be real or non-real. We cannot forget that. Roots can either be real or non-real. If it's non-real, discriminant is less than 0. If it is real, they could be equal and unequal. Just by that word, equal, it means discriminant is equal to 0. Unequal, discriminant is greater than 0. Now, the third one is that your root could be rational. If that's rational, this is a perfect square. When we say it's a perfect square, when you solve, you must get something with a square. Summary of nature of root. Done. And what is your discriminant, by the way? B squared minus 4AC. If you just remember that, all questions of nature of roots are then simplified. Again, I think I did post something on nature of roots of recent. Posted on YouTube and send the link to you again. Just please make sure you go through those little concepts. Okay, now, examiner says have what? Equal what? Roots. First thing that comes to my mind, discriminant must be equal to what? 0. And before you get your discriminant, please make sure that you write it in standard form. Is that okay? But this already is written in standard form because it's ax squared plus bx plus c. It must be equal to, it's compulsory standard form. Because you will not be able to get your a, b, and c. All right. They said we'll have equal roots. Please mention, for equal roots, I want to show you something very important. Discriminant must be equal to 0. Do you know that's 1 mark already? For just mentioning that. What's our discriminant? B squared minus 4ac. Now, what is your b? B is the coefficient of x. Do you see that? Bx. It's just me putting that x at the back there. So what is my b? 2p plus 4 all squared minus 4. What is our a? 1. What's our c? 9p. Please, very important there to be able to separate your a, your b, and your c. And please, I know out of pressure, some of us still distribute. That is, I don't know what to say there. We don't distribute. What do? We expand. 2 brackets. All right, I'm not going to do 2 brackets. No. 2p times 2p. 4p squared. 2p times 4. 8p times 2, because you have 2 brackets. 16p plus 16. We good? Minus 4 times 1. Minus 4 times 9p. Negative 36p equals to what? 0. Can we simplify and solve here? I think we can. What do we have? 4p squared minus 20p. For me, I'll divide by 4 because they're all multiples of 4. P squared minus 5p plus 4. Do you think we can solve this? Lovely. Equals to 0. What are we looking for? Factors. P minus 1. Beautiful. So P equals to 1 or done. 4 marks. So you'd have gotten a mark for saying discriminant equals to 0. You'll get a mark for the substitution, you get a mark for the factors, and you get a mark for your answer. And that's why the examiner says, for which what? I know some of us have never paid attention to that S. It's fine. Even if you don't write your discriminant equals to 0 from the top, but you write it somewhere, it's 1 mark. No, just say discriminant. You even need to put the word let. Just say discriminant equals to what? 0. You get your 1 mark there. Okay, we'll just ignore the let that you wrote and just say because that's what we want to mark. We want to mark that statement that says discriminant is equal to what? 0. Mbonga, please ask. Good. If it says it has unequal roots, then we say our discriminant is greater than 0. Greater than. Then we solve using critical values now. Make sense? For which value will it be unequal? It means your discriminant will be what? Less than, will be non-real. No. All right? So I think what's on the left is what is key for us here. What on the left is key. So I hope you're okay. This is question 1 down the line. Just a reminder, just to remind us of the things that are needed to be seen. All right. Just a second. Okay, let me give you this. Let me go to the next slide and see what's there. Oh, now we are on number patterns. Okay. Number patterns. I hope you still remember. Okay, and this is a quadratic. In fact, guys, the 4 marks, these 4 marks must be well received and well attacked. It's a quadratic. Can I just go straight to solve it now, right? 1, -5, -13. We know we need our first difference. -5, -1, -6. Very important, please. You see, in this exam we're going for, let's be very careful. You don't need to do too many things. But whatever you do, get the marks right. -13 minus -5. If you need to use a calculator, please use. What's your answer? -8. What's the next one? -10. Now, what else do we have? Second difference. -8 minus negative. What do we have? -2. Now, what else do we know? 2a. 3a plus b. A plus b plus c. Okay? So 2a equals to -2. Let me increase my pace. 3 into -1 plus b. I'm just substituting. We all should know this, right? What will this give us? -3. And what is our c? -1, that's my a. My b is plus c equals to 1. -4, c equals to what? 5. So what do we have? Tn equals to an squared. What's my a? -n squared minus 3n. All right, done. 4 marks in the bag. Just something that we should expect. And by the way, you should know that if my a is negative, guys, it's a quadratic. If your a is negative, you're going to have what? A sad face. What does that tell you? It tells me that there's somewhere here which is going to be what? Maximum. Because examiners will tell you to find the maximum value. Thank you, Leslie. How do you find the turning point of a parabola? N equals to minus b over 2a. What is our b? -3 over 2. What will this give us? minus b, or minus 3, right? So can we say positive 3 over 2 times minus 1 minus 3 over 2. All right. In this case, our maximum point is before 0 and it's a decimal. But what I'm trying to show you here is the principle. Examiner is going to ask you which term is the largest term, or what is the value of the largest term. We need to know how to do this by saying n equals to minus b over 2a. It's a parabolic function because a quadratic function is a parabola. I could look for a question. I could create one that would work out so that we see. Anyway, 2.1.2. Which term has a value of negative 643? What do we do? We just equate now. Please get me in, everybody. This I'm not doing. Some people have done it, some have not. I'll give you a chance. I just need to make sure that these small concepts are well put in place. Let's get n, algebra, quickly. Okay, answers? I'm seeing 24. N squared minus 3n minus 5 minus 643. I just brought everything over to the side. So n squared minus 3n minus 648. I'm sure you are going to use a calculator here. 27 and 23. That's the answer I'm getting from 20. So n minus 27, n plus 27, n minus 24. So n equals to 24. N cannot be equal to, because we're talking about number of positive terms. All right, so please remember this basic concept again of factorization and solving. Use your calculator. Minus b plus or minus b squared minus 4ac. You don't want to show that you're a pro in the exam. No, you want to do basic things to get those marks. I hope you're okay. Look at this one. Now, this is grade 10. 2k plus 1, 3k, 5k. And I know when we see these k things, we just lose hope. Like, oh my God. No. It's an arithmetic sequence. What do we know about an arithmetic sequence? It has a common difference. All right. Arithmetic has what? A common difference. And what does that common difference mean? T2 minus T1. T2 minus T1 equals to what? T3. Just by looking at that, already you've gotten your K. What do we know? What is my T2? 3K. What is my T1? Is that correct? Really? T3, 5K minus 5 minus what? 3K. That's just one term. There's no need for a bracket there. So what do we have? 3K minus 2K minus 1 equals to what? 5 minus 3. 2K minus 5. What will this give me? K. K minus 2K. I've already brought my 1 over. Take that 1 over. What do you have? Minus K equals to minus 4. Is that what you have as well? K equals to 4, Bibi? K is equal to 4. K equals to 4. Sigma notation. Do we remember sigma notation? Funny E. Spade, do you remember how to write sigma notation? Do you remember how to get your sigma notation? It is this sigma, and you must look for what? Tn. Get that. And then n would be the first position and up to what? The last. That is how to write your sigma notation. Okay, write down the sigma notation for the first 20 terms. Already I know my n is 1 up to 20. The question is, what is Tn? It's not easy to get Tn just by looking at that equation. You need to change everything into numbers. What's the first one? 9? Okay. 9, 12, 15. What's your common difference? 3. 3, right? Okay. Do you know I can get my Tn like this straight without even calculating? Let me prove it to you. You did it, right? Yeah. That's a very short way. Let me show you what I did. Oh, sorry. 9 minus 3 plus 6. Plus 6. Let me show you what I did. Your Tn is Dn plus A minus D. What's my difference? 3. That's my 3. N. Then I say A minus D. You see, it's when we start, that's when we start doing Tn equals to A plus. Now we must move. Bonga, you seen that for the first time? Hey, yeah. But you understand what I did? It is, check what I did. What's my difference? 3. You get the difference is 3, right? Good. So I'll say 3, that's my difference. N. Now that is A, and this is D. What is A minus D? 9 minus 3. Positive 6. We're done. That way, you get your answer, Papa, you move. So what's my answer, final answer? 3n plus 6. N equals to 1. They said the first 20 terms. We're done. 3 marks in the bag. Yes, Leslie. You don't need to do formulas. Even if you go straight, you'd get your full marks. Because there are so many ways to do that. So you can go the full way, you'll get your marks. So dn equals to tn equals to dn plus the difference between a and d. You're done. Now, Bibi says if you put your tn in bracket like this, does it matter? No, it doesn't. All right, so please, are we okay there? That's how you, please don't forget this sigma notation formula. It's tn there. Just put your tn, first 20. And you know what sigma means? Sum. All right, Sn equals to n over 2, a plus n minus 1, d. Please remember those proofs. Do you remember how to prove this? Sn equals to n over 2 into bracket 2a plus n minus 1d. And also, Sn equals to a into bracket that proofs. Anyway, I'll be doing those proofs. You can check my Instagram reels. Instagram matric reels. Crazy physics. I'll be sending all of those proofs there. If you don't follow me, you won't get it. And if you don't get it, you can forget about it. All right, look at this geometric sequence. Ashley, you don't have an Instagram account. Are you born in 1724? No, man. Just open one and follow me only. Just follow. Let me be the only one you're following. Or TikTok. Okay. Leslie, it's like you were born in 1322. You don't have Insta? Like really? As old as I am, I've got Insta, man. I've got personal Insta. I've got business Insta. I'm on Facebook. Outside of social media. All right. What I'll do is whatever I post on Instagram, I'll definitely send to you guys by WhatsApp. It's going to be short, so 2 minutes will be fine. Because all right, let's quickly answer this. Given the geometric series 8x squared plus 4x cubed plus 2x4, it says it's a geometric. What are we looking at when we say geometric? Don't forget those keywords. We are dealing with what? A ratio. For which values? Biggie, I did this on Saturday. What is converge? Good. It means not just numbers. Your ratio must be between -1 and 1. Yes. Good. So now, we need to get what? We need to get our x. No, we're looking for x. So how do we work around this? What is our r? T2 over T1, right? T2 over T1. So 4x cubed over 8x squared. What's this? What will this give us? Sorry? X over 2. That's our R. Step by step. Okay. 4, 1. Lots of exponents here. 3 minus 2, 1. So it's x over 2. Okay. What do we have? 4x to the power what? 3 over 8x to the power 2. 4 divided by 8 is half. laws of exponents. When you are dividing with the same base, what do? You subtract. And you subtract where it's more. So it is that. And that is basically x over 2. We okay now? All right. I'm just waiting to make sure that we're on the same page. Are we okay? But we are not really looking for x over 2. We want a value. What is my convergence? -1 less than r less than 1. Do I know my r now? X over 2. What do? Multiply across by, because you want to get rid of anything that is not or that is associated with the x. So multiply everything by 2. What do you have? -2 less than x less than what? 2. Done. What's that? Next time going to be? Oh, it's very easy. You see that the numbers have been divided by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. So what is 2 divided by 2? 1. And your exponents are increasing by 1. So it's x to the power 5. Half x to the power 6. No, it's just maths, guys. Just maths. 2.3.2. Calculate the value of x if s to what? If s to infinity. Interesting. S to infinity is 8 over 3. You know what? Learners always find this a bit challenging and not know where to start from. Why did you change this? It has a formula. What's the formula? A over 1 minus, okay, let's write that. All right. Let's start from there. S infinity equals to A over, it's there on the formula page. Now we know our A. Remember we are solving for x, right? What's our A? So we are saying A over 1 minus R equals to what? 8 over 3. Baby, what's our A? 8x squared over 1 minus. Oh, there's a lot of fraction here. Huh? Okay, let's do it step by, because I know this is where Elena says, yeah, I'm doing something wrong. Okay. I would say, Biggie saying we should break up the division. All right. Makes sense? So it will be 8x squared divided by 1 minus x over 2. I want us to make sure we get all the marks. This is 1 over 1. And I remember teaching you how to deal with DDD, diagonal, diameter. Denominator. How to deal with fractions. Diagonal, denominator. All right? Diagonal, denominator. Okay, so don't forget fractions. It works that way a lot of times. Let's see. Leslie, you also did it this way. Beautiful. 8x squared. I'm still using divided by, right? Diagonal, 1 times 2. 2. Minus, next one, x times 1. X over what? 2 equals to 8 over 3. Let's just make maths a lot simpler. Before you take anything over, let us change that division into what? Multiplication now. So let's make maths enjoyable and swift to do. Let me just move this. Let me move this so that I have space. I want us to enjoy maths, like have fun when you're doing this. Okay. What do? We're saying we can change that, right? 8x squared times 2 over what? 2 minus x. Are you okay with my over? I've already multiplied. Equals to what? 8 over 3. Please don't cancel. Don't. Why can't we cancel? Because it's 2 minus x. We rather do what? Cross multiply. 3 multiplied by, and okay, let's make it easy. This is x squared times 2 would give us what? Because I know some of you would multiply this 2 by 3 and still multiply this 8 by 3. Don't do that. 2 minus x equals to what? 8 over 3. Now can we cross multiply? What is 16 times 3? Sorry? Why are we cross multiplying? Okay, what would you do, Biggie? We're done with that. We're cross multiplying. There's no, yes. Okay, what would you do? Yes, so the only thing to do is to cross multiply. You cross multiply when you have two fractions and there's an equal sign in between them. Hello? Two. The reason I didn't do that was this. I said I wasn't going to do that at that point was, if I could cross multiply, trust me, that way. But what you are likely to do is to say 3 times 8, 24, and then still say 3 times 2. And I'm trying to avoid that. Now, okay, Biggie, what would you have done here? Quickly. No, tell me what's in your mind. No, talk to me. Don't use a calculator now. Talk to me. Tell me give me an instruction. To do what? Okay, all right, hold on. 2 over x equals to 3 over 7. What is x? Let's quickly go back. Huh? I should cross multiply. Okay, what's the difference between this and that, what we have on that side? So we cross multiply. All right, 40. No, I just want us to get the principles. 48 x squared equals to 8 times 2, 16, minus what? 8x. So what do we have? 48x squared plus 8x. I already see instantly that I have a trinomial again. And that's why the examiner again said, check. What are the values? So, can we divide by 8? Just to simplify. What is 48 divided by 8? 6x squared plus x minus 2. All right, do you want to factorize? I have a 4 and 3 there, somewhere there. Okay, I'm doing my own way in my head. Okay. Huh? All right, guys, give me your answers here. I know you can all factorize. All right, for me, I would do this while you are busy with yours. Maybe this is what I say when I say 4 and 3. But I had multiplied by 6. So I need to divide by 6. This is 2 over 3. So I have 3x plus 2, 2x minus 1. Okay. Three x plus 2 and 2x minus 1 equals to 0. It means x equals to negative 2 over 3 or x equals to half. Tess, please check. You're giving me 1 over 3. Is it 1 over 3? Am I making a mistake? I'm right. Tess, please check. You made a mistake somewhere. All right, anyway, guys, all these algebra things are things we should be consistently doing. It's okay, Tess. But the principle, are we okay with the principle? So change S infinity to its original formula and then solve. Okay. Bibi, you were saying? All right, let's see. The first, third, and 13th term of, look, let me tell you something here. When you see these kind of questions, please change from English to maths. How? All right, lovely. The first, third, and 13th terms. Look at my changing this into maths. The first, T1. Third, T3. 13th, that's what I know first. Of an arithmetic sequence are the first three terms of a geometric sequence. Beautiful. Beautiful. If the first of both sequences is 1, already I know my first term. Let's do this. Let's do this. What is the first term of the arithmetic? Let's do this together. I love this. T1 equals to A. What is T3? A plus 2D. Tn equals to A plus n minus 1D, remember? What about T13? A plus 12D. Do we agree? They said these terms are the what? First three terms of a geometric. Oh, let's see. So what is my geometric? It's A plus 2D. I don't know if it makes sense. T1, T3, T13 is T1, T2, T3 on this side. This is just me interpreting. If both of them have what? If the first term is equal to what? 1. What does that mean? My A is 1. Oh, so what do I have here? This would be what? 1 plus 2D, 1 plus 12D. Make sense? We okay? 2.4.1. Determine the first three terms of the geometric sequence if R is greater than 1. Okay, 6 marks, and you chicken out here. Okay, let's see. So, arithmetic. Let me just get a fresh page. We have 1. Our T1 is 1, right? Our T3 is 1 plus 2D. And our T13 is what? 1 plus 12D. Interesting. For the geometric, what do we know? It is 1 plus what? 2D, 1 plus 12D. What's my ratio here, since they want a ratio? Is it okay to say our ratio is 1 plus 2D over 1? T2 over T1. Right? And that same ratio is what? 1 plus 12D over... Does that make sense? We good? T3 over T2 equals to T2 over T1. Sorry? No, because it's a ratio. It should give us the same. So we're going to equate them. It should be what? 6D. How? Amen. So 3 plus 4 over 3 plus 3. What's your answer? What? Nope. So you are going to say 3 would cancel 3. Amen. Okay, use your calculator. 3 plus 4 is 7. 7 over 6. Yes, I'm listening. T3 over T2. Yes. Cross multiply. No, I mind you. No, I mind you. I mind you a lot. Over 1. So what do? We cross multiply. Again, do you see we're cross multiplying 2 fractions with an equals? Fahima, no. Who used to have a problem with cross multiplication? I think, was it Fahima? Fahima, was it? Is it that? Yes, cross multiply. It was Fahima from grade 10. All right. Cross multiply. 1 plus 12d times 1 will give me 1 plus 12d. And this is 1 plus 2d multiplied by 1 plus 2d. 1 plus 2d squared, right? So 1 plus 12d equals to what? 1, and then 2d will give me what? 4d plus 4d squared. Can we move everything over to one side? 4d squared. If I move this 12 over here, it becomes what? A negative. And 4 minus 12 will give us negative 8d. This 1 and this 1. Oh, beautiful. Actually makes my life easier. So we can factor out d now. Sweet. D into bracket what? Okay, we can actually factor out 4d, but it's fine. 4d minus 8. So it's either d equals to 0 or 4d minus 8 equals to 0. 4d equals to 8 and d equals to what? Okay. Biggie says let's factor out 4d. Can I do it just below here to save space? Here. 4d is common to both of them. So what do I have? 4d. What am I left with? Minus. All right. 4d. Okay. So 4d equals to 0 or d minus 2, which gives us d as what? 2 and d as 0. But we're not done. We're looking for r. But we know. Good. So, yeah, I know you're clever. Child. 1 plus 2d. So r equals to 1 plus 2 multiplied by what? 0. What is r? 1. Or r equals to 1 plus 2. What's the other d value? 2. So r equals to what? 5. They said the first 3 terms, if r is greater than 1. So which number is greater than 1? R equals to what? 5. Baby is killing me. R is greater than what? 5. Automatically, we can get our terms now. It says, what are we looking for? The first 3 terms of the geometric. I already have the first one, which is 1. Okay? So my geometric will be 1. We replace 5 there, right? 2 times 5? 10. Plus 1? 11. What's the third one? 5 times 20 is 60. Plus 1. 61. Oh, sorry, 5 times 12. It's 12d. Oh, no, sorry. No, sorry. Okay, no, I made a mistake. We have our r as 5, right? Okay. But we are looking for the geometric. All right, wait, when did we get 5? We got 5 when d is 2. My bad there. We got r as 5 when what? D. Remember, here d equals to 0. Here d equals to what? 2. The examiner says we should choose the one where r is greater than 1. Where is r greater than 1? D equals to what? 2. So we go back there. It's 1 plus 2d, 1 plus 12d. So it's 1. What is my d? 2. 2 times 2? 4. Plus 1? 5. What's my d? 2. 24. And it makes sense that my R is 5. 5 divided by 1, 25 divided by 5, 6 marks. So I don't know if it makes sense, guys. It's just to follow and check what is it that we can do. Tess, you could have done that as well. Sorry, Tess was saying, sir, can't you just do 1 and then say 1 times 5? Yeah, you're fine. As long as you get 1, 5, 25, you're fine. Bibi, your question again? You'd lose 1 mark. Why? Because the question examiner says find the first 3 geometric terms. Please, can I get a feedback from you all before we move to the next stage? Quickly, please. I'm not even sure what this question is again. This is 2.4.1. Please let me know what do you think. Are you okay with what I did? Please, I won't move forward until I get a response from you all. Guys, are we okay here? Any question? I'm waiting for those guys online to let me know. All right, Ashley. I'm waiting for the rest to see what I need to do. Ashley, I got your message. All right, I've got 2 requests saying I should re-explain. Let's quickly look at it. But I hope you understand the question. The first thing is it's a word problem, guys. We change it into maths. Is that okay? The first, third, and 13th of the arithmetic are the first 3 terms of a geometric. Guys, don't read. No, we pause there. What are they saying? First, third, and 13th of an are the first 3 terms of a geo. This is what I did here. So this is my arithmetic. And please don't forget these formulas. A plus n minus 1 d. All right, we are supposed to find what? The first 3 terms of the geometric if r is greater than 1. All right, I just rewrote my information now, knowing that my what? A is 1, right? And I'm thinking, okay, look, what is it that I can do? Somebody's saying, what if I had started with, let's check something. I want to try something. If I'll get stuck. Just wait, I'll come back to explain. What if I decide to run with my arithmetic? Just want to remind us of the principle that the problem will be 1 here. T13 minus T3 All right, it's a principle. What is 13 minus 3? 10. It should be 10D. Multiple difference. I lost you there. No, I'm not. I'm just trying to look for another method. All right, to see if you're going to get stuck. Also reminding you of that principle called multiple difference. Look, what is my T13? T13 is usual. Look, it will even work. That's why this one we're going to get stuck. Check this. What is my T13? 1 plus 12D minus, what is my T3? Remember, you must put a bracket there. What are we going to get? 1 plus 12D minus 1. The 1 would go. What is 12D minus 2D? So you see, I'd have 10D equals to 10D, which is not making any mathematical sense. So I am stuck here, which means my other way is to go through the geometric one. So what did we do? It's a ratio. We know that what? T3 over T2 equals to what? T2 over T1. We're good? Do I know my T3? Do I know my T2? Do I know my T2 on the right-hand side? Do I know my T1? The rest is all. What do we do? Cross, multiply. As long as you don't multiply the first and last, no. The rest, you are okay, we got our D, right? But we are not really interested in D at the moment. They said if R is greater than 1. So I came back here to say, okay, when D is equal to 0, what is my R? 1. I am discarding that. Why? Because the examiner wants your R to be greater than 1. When D equals to 2, what is my R? 5. Oh, so this is the D that we are going to use because of the instruction that we were given. We together? All right. So all we needed to do, since we know our R is 5, okay, this was where Tess was saying that since we have already agreed that R is 5, our first term is 1. What's our next term? Our next term, I don't know if you guys remember this, that for a geometric it is A, it is AR, and it is AR squared. Because your formula, no, this is the general formula. So what is my A? 1. What is my R? 5. So 1 times 5? What is my R again? 5. 5 squared? 25. 25 times 1? So please don't forget the original root formulas, okay, of your geometric and your arithmetic. It's all there on the formula page. I hope I've been able to get you now. Tn equals to what? A plus n minus 1d, where d is T3 minus T2, which is equal to T2 minus T1. Tn equals to AR to the power n minus 1, where R is T3 over T2, which is also equal to T2 over T1. What is this? Arithmetic. And what is this? Geometric. All available on the formula page. Ritumeti, Ashley, please talk to me. Are we okay? We're good? Lovely. We okay? So remember the root formulas of where we, and these things are on the formula page, especially the Tn formulas. Okay. Ooh, we get the functions. We get the functions. are basic things that everyone must be able to do on functions, like basic level 1 things that we must be able to do. Our basic. Okay, what can you tell about g of x? Okay, what type of function is it? G of x is y, f of x is y, h of x is y. But what is g of x? It's mx, it's a straight line. All right? That's a straight line there. And what's the equation of a straight line? Y equals to what? Mx plus c. It means my m is -2 and my... What do we know about c, by the way? C is known as the y what? Intercept. Look, let's go to that graph quickly and check. I know this point already. What is that point? 8. I know. But remember that you're 0. And these things are not drawn to scale, so... Okay. All right, are you okay there, though? So that is me interpreting the graph. What is f of x? There's a squared there. It's a parabola. X squared plus c. That's a parabola there. What about h of x? It's a hyperbola. So this is the 3 graphs locked up together. And what do I know here? Asymptotes. X equals to what? 2. Y equals to 1. Already check. It means this point is 1. All right? Yeah, it's very close. F of x is exponential. No, sorry. There's no exponential here. F of x is parabola. Okay? And what is my... That's 2 there. So those are the first things I'm able to pick from the graph. Is that okay? A and B are the x and y intercept. We must be able to get intercepts there. All right. C is -6 and 20. E, okay, all of those funny things just there. By the way, do you know I can get the value of E, though? E at the point of intersection of F and G. Do you think we can get that point? Please get that point for me. Let me see what you would do. They told us that E are the, okay, A, B are the X and Y intercepts. Where is B? Or of H respectively. And C, -6 and 20. And C and E are the points of intersection of F and G. Beautiful. I'm just looking for that. I'm looking for the x-intercept of G. If you have an answer, throw it in. Arithmetic says 4 and 0. I'm only getting 2 answers, 4 and arithmetic and BB. Please, I need everyone. Bonga. What did you get? Oh, Tesmia just typed same. She didn't do it. She just typed same so that I don't shout. Tess, I know right now you are laughing and laughing wherever you are. Okay, you did. All right, thank you, guys. Ashley also doing yellow. Lovely. What would you have done? You are looking for the x-intercept. Y is supposed to be what? 0. So, what do we say? 0 equals to minus 2x plus 8. 2x equals to 8, and x equals to what? 4. Done. Okay, let's go look at these questions from, I'll see and answer as many things as I can, even if they don't ask us yet. I want to revise our functions immediately. Calculate the coordinate of A, B, and E. A, B, and E. Oh, do you notice we're already done with E? E we're done. All right? E is what? 4 and 0. Do you want to get me A and B? What do you see? What would you call A? What is the name of A called? Another intercept. Just another intercept. It's x-intercept, baby. It's not another intercept. And what is B called? Y what? Now, this would help our minds quickly. Once we describe it that way, it helps you to see. And on which function? It's the hyperbola. And which one is the hyperbola here? They even told us A and B are the x. You see, the problem is reading. Everybody get me x and y intercept quickly? How many marks? We would see later on. Please, let's get x and y intercept. All right, Mary is done. Mary says A is negative 4 and 0. B is... Okay, Mary, please check again. You have 2 B's, and I'm not sure which one I'm following now. Okay, Ashley, please check. The people here are saying B is 0 and negative 2. Mary says B is 0 and negative 4. Biggie is analyzing answers here. Okay. Right, h of x is 6 over x minus 2 plus 1. So we are saying y is 6 over x minus 2 plus 1. Let's do it together. What will be our x-intercept? Y should be equal to what? 0. So 0 is 6 over x minus 2 plus 1. We move that there. It becomes what? Negative 1 over 6. We cross multiply. Now what do you have? X plus 2 equals to 6. Negative x plus 2 equals, thank you. So that would be what? Negative what? 4. Make sense? All right. And then for our y-intercept, x should be equal to what? 0. So what is y? 6 over 0 minus 2 plus 1. What's your answer? Negative 2. But they want the coordinates. So this is a, right? X is what? Negative 4. What about b? Y is negative 2. All right, we already have our A, B. Now, already we got our E earlier on, right? Okay, check how many marks. 4 marks. Oh, so little. Show that the value of Y, of C, is negative 16. Do you want to try? What would you do? 16. C. Check the equations. There's C somewhere there. Try it quickly. Show. Let's see. Show. C, we see C is on f of x, right? So go and trace your f of x. There is something on that graph that we know. Trace it. There's a point that we know. Oh, we know 2 points. Ah, come on. You should be done by now. Once you're done, let me know. 2 marks in the bag, quickly. We're moving on well. Guys, you see, revision is now in place. Full revision. Are we done? Tell me if you're done. Please get me answers quickly. Once we're done, let me know. We're wasting time. When we're done, just say done, 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 done. And if you're not getting it, please let me know as well that you are not getting it. Okay. Sorry? I need to know who else is stuck. Richmate is stuck. All right, the examiner says we should find what? Examiner says we should find C. Look, what I need to check is this. My C is on f of x. Go to your f of x. Is there a point you know? Oh, there's a point here, 1. There's another point here, easy. That is your x, and that's your y. We also know this point. 3 points. This one. Which other point do you know? A. Oh, yeah. So they are so, guys, we know this point, we know this point, we know this point. We could have used any of the points. I want to use the C. Why do I want to use the C? Should I have made mistake here? Let me use what they gave me. Make sense? -6 and what? 20. Let's walk through. So what do we know? I hope it makes sense now, guys. Those of you that have forgotten and got stuck. What do we have? Y equals to what? X squared plus C. And we're using what? -6 and 20. It means this is 20 -6 squared. Make sense? What do we have? 20 equals to what? 36 plus C. Move that there. C equals to, we're done. That's what you do with functions. All right, write down the values for which g of x minus f of x is greater than or equal to 0. Learners don't like this part. No, we're not skipping. 2 marks means you should get it. G of x minus f of x. Please, I want you to change your attitude towards this question. I know it's not just you, baby. A lot of learners just don't like this. Minus f of x is greater than. Let's simplify this. This means that what? G of x is greater than or equal to what? Make sense? Just move your f of x over. If I write g of x is greater than f of x, you know what it means? It means g of x is above. And if I write g of x is equal to f of x, you know what it means? They are what? Equal. And what are we looking for? Point of intersection. So examiner is asking us to combine both now. Do you see my interpretation there? I'm going to get this graph out for us. Let's take this graph to a new page. F of x. All right, and not just that, I am going to actually cut this out. I want something very, very big. There we go. What are we looking for? F of x is greater than or equal to what? G of x. In an exam, you could use color pens to make it easy for you. All right? Let's see. This is my F. Is this blue okay? No, I wanted it to stay there. F of x. And what? G of x. Let's use red. Okay, now let's highlight. Let's use the turquoise one to highlight. All right. F of x is above what? G of x. Let's check something. It's very important here to see. Look, this is your F. Can you see that we're using this point? G of x is above what? F of x. What do you notice here? Here, this is blue, right? What is one is the blue? F. Okay? So we are saying here, at this particular point, which one is above? F of x is greater than G of x. And that's how you interpret the graph, guys. It's not something very hectic to do. Here, F of x is greater than G of x. But what do you see in the middle here? The red one is above now. So what do we know? G of x is greater than F of x. Immediately after we pass that section, what do you see? F of x is greater than. Do you see how easy it is to look at? What are we looking for? G must be above what? F. Where is that? The one in the middle. Oh, beautiful. So we at between what? C and E. In terms of coordinate, I have already answered you there. Less than. Examiner wants x for which values of x? So what is the x value there? -6. What is the x value at E? 4. X being an element of. However, we're not done. They said g of x and also what? Equal to. Where are they equal? Just at that point of intersection. Just put an equal sign and you are done. If you forget your equal signs, maybe you get 1 out of 2. You need to get the 2 here. Please, are we okay with what I just did? Are we okay? Please, can I get your responses? All right, sweet. We're good. Let's see the next one. Right, determine the equation of the axis of symmetry of H if the gradient is negative. So easy stuff. If the gradient is negative, let's see. What is our equation? H of x is equal to 3. No, it's 6. Is it 6 or 3? 6 over x minus 2 plus 1. 6 over x minus 2 plus 1. By the way, do you see that this can be written as y, right? How do we write the axis of symmetry? There we go. This one is y equals to x minus 2 plus 1. Y equals to x minus 1. But this one is a positive what? Gradient. Make sense? Huh? I'm getting a positive answer here. Yeah. If I want a negative gradient, check what I do. I'll just come here. Negative gradient means all of this, and I put a negative in front of it. So my equation still goes the same way. What will I have? Y equals to what? Negative x minus 2 plus 1. Negative x plus 2 plus 1. What's your answer? This one is a negative what? Gradient. Please, don't let's forget this basic. That's why I said there are some questions that are basic for everyone to get. We okay, everybody? All right, sweet. Let's see. What we'll do is we'll stop on this one so that when we come the next time, we are fresh again for the remaining part, the inverse, financial maths, calculus, counting principles, and all of those. But I want us to make sure whatever we do is well done, and we all get it, we're able to break it into small aspects. What do we have here? Show that the length of BE is 2 root 5. Let's see. Where is BE? Okay. Do we know the coordinate of B? Do we know the coordinate of E? The length. When they say length, what are they talking about? Beautiful. Please, let's get the distance. BE. Just in case you've forgotten the coordinate of B, we have it there. What did we get for E again? All right, everybody, let's practice that. Now, somebody's saying, but that is paper 2. We don't care. It's maths. All right, let's get it. All right, are we done? Monica is done. Ashley is done. Lovely. Tess is also done. And Bibi just did something extra smart now. I love it. I love what you did. I love what you did. Actually, it's easier. What is the coordinate of B again? That's -2 there. What is E? 4. Guys, that's 90 degrees. Smart. Extra smart. And if it's a 90 degrees, what is that? Theorem of Pythagoras. Very good. Very good sight there. And BE becomes my hypotenuse. Very smart. So we would say, yeah, it's the same. There's nothing wrong with that as well. OB squared plus OE squared. It's the same representation as the distance formula. All right? So BE will be equal to the square root of, what's my OB? It's 2 squared. What's my OE? 4 squared. What is 4 plus 16? Root of 20, which is 2 root 5. Whether distance or Pythagoras, as long as the maths principle is okay, we are fine using any principle. Let's check this quickly. No. Where am I going? Write down the range of S. Ooh. If S of X equals to H of X plus... Let's discuss this quickly. I want to discuss something here. Write down the range of what? S. We're still dealing with the hyperbola, right? Where's that equation? Okay, good. Let me work with this page since we are still on the hyperbolic function. What is the range of an hyperbola? all values of y, but y cannot be equal to the asymptote. What is the domain? All values of x, but x cannot be equal to the asymptote, p. And let me show you how examiners will write this again. And I'll explain with numbers. Is that okay? Examiners will tell you negative infinity to q union q to positive infinity. This simply tells you your asymptote. I don't know if it makes sense. So let's check something here. I'll answer the question, but let's deal with h of x first. 6 over what? X minus 2 plus 1. What's your asymptote here? We said vertical asymptote. I normally say vax. X equals to what? 2. Horizontal asymptote, hey, 1. What is my range here? Y is an element of real numbers, but y should not be equal to 1. Does that make sense? And how can I write this again? Y is an element of negative infinity to 1, curved bracket, union, 1 to what? Positive. So you are seeing all values from negative infinity to positive infinity except 1. So examiners, you'll find this in a question, and they expect you to know that the asymptote there is 1. What about your domain? I'm going to answer the question, right? We're dealing with S. What about my domain? X is an element of real numbers, but X cannot be equal to 2. How would I write it? X is an element of real numbers up to what? 2, but not inclusive. Union 2 to infinity. Make sense? But the examiner says S of x is h of x plus 2. What have they done to the graph? Bonga? S of x is h of x plus 2. What have they done to h of x? They shifted. Where? Horizontally, vertically? I should go back to the previous slide. It has nothing to do with this, though. I'm saying S of x is given as h of x plus 2. They've done something to h of x to get to S of x. What did they do to h of x? Tesmia. Wrong. Huh? Okay, guys, there's a difference between this and this. Good. When it's in the bracket, this is what? Horizontal. And it's plus, it means it is what? Left. This one is outside. It's the whole of that plus 2. It means it's what? A vertical what? Shift. And where? Up. How many units? 2 units. So we could come here and say 6 over, what is it again? X minus 2 plus 1. That is my h of x, right? Now, do you see plus 2 outside? What does that give us? 6 over. What is our range here? Y is an element of negative infinity to 3. 3. Or you can say what? What's your other way of writing? Y is an element of real numbers, but y is not equal to to 3. Or you can do this. So we must know how examiners are going to represent all of that. And you must know your shift. No, you don't need to show it. Because I could walk around even from the first one. What was our original equation? H of x equals to what? 6 over x minus 2 plus 1. What was your range? Y is an element of what? Real numbers. Y is not equal to what? 1. But this graph, S of x, it has now gone up by how many units? 2. Move that up also by 2. Yeah, that's what I'm saying. This one here. Because your asymptote has shifted. So it's y is an element of real numbers. Y is not equal to 3. I'm just showing steps. The examiner doesn't require you to show. But we must understand the steps. I hope it's okay. We're getting there. Everything that we've done, January, February, March, April, coming back, right? Okay, please. I'll make this available on YouTube so that you can quickly just watch it. Because it's the whole thing. Okay, let's look at the last question, I think. And we can rest it there. 5 marks. Okay, what a good way to end. If T is a tangent to F and parallel to G, sweet. Oh, the way you said, oh. No, let's do something. Let me try to make it easy for you. Don't try to assimilate all the statements at once. Can we stop there? If T is a tangent to F and parallel to G, let's go and create that tangent. Let's see something. Let me create a fresh graph for us. So this is what you do. Don't be overwhelmed by all the grammar and whatnot. Circle? We don't need. We need a tangent. Okay, let's go back again. I want to get... They said if what? T, is it T? Tangent to F. But it must also be parallel to what? To G, okay? Tangent to F. F is my parabola, right? But parallel to what? G. Beautiful. It must be a tangent, but it must be parallel. Let me do this. There we go. I don't know if it makes sense. Okay, no, this whole equation is T. They said if T is a tangent and it is parallel. Do you know the first thing I know? I know the equation of this line. Y equals to negative 2x plus 8. My gradient is negative 2. Already I know the gradient of this line is what? Y. Parallel lines have equal what? Gradient. That's the first information that I come across. Do you see? I'm not overwhelmed by the long statement. Now, can I go back and deal with the rest of the statement? What are we looking for? Determine what? The equation of T in the form y equals to mx plus c. All right. So, I want this equation. Analytical geometry now. This is both analytical and Euclidean. If I want the equation of a line, what do I need? The gradient and 2 points. And one set of coordinates, one x and y. And which x and y do I need? I need this. If we can get those points, then we are done. The question is, how do we get this point? Let me see. I want to do this in 2 ways for you quickly. All right. Now, that's a point of what? Intersection. Biggie, you're coming up with a very, very important stuff there. Already, do you know that I know this equation as y equals to minus 2x plus c? Do we agree? But I do not know C. C is my problem. But I cannot get C without getting x and y. By the way, I do know this equation as what? X squared minus 16. Do we agree? Do you remember f of x? Do you remember that, right? Good. Now, this is a point of what? What do? We equate. Because we are saying y equals to x squared minus 16. Y is also equal to what? Negative 2x. Somebody's saying, okay, what if even if we equate, what's going to happen? Let's check something here. And please take note, this is a very common question. So point of intersection. Let's see quickly. Running out of time now. We are saying f of x is equal to t of x, the tangent. X squared minus 16 equals to what? Negative 2x plus c. Ooh, we still have two unknowns. Can we bring everything over to one side first? What do we have? X squared plus 2x minus 16. Do we agree? Please take note of this. At the point of intersection, the roots are equal. We're going back to nature of roots. At the point of intersection, what? Roots are equal. Wait, what is the condition for roots, equal roots? Do we remember? Baby? Yeah, we did something like this. Okay, it's fine, but give me, when roots are equal, what do we say? Discriminant. Yeah. Discriminant is equal to what? 0. Okay. All right. Triangle. All right. What is the formula for the triangle? V squared minus 4AC. Now, what is our B? The coefficient of x. 2. What is our A? Now, what is our C? Negative 16 minus C. This whole thing is C. Remember the equation. It is what? AX squared plus BX plus C. Make sense? I'm glad we're actually looking at this. It's bringing a whole lot of things back. Can we simplify? 2 squared will give us what? 4. 4 times 1, this is minus 4, negative 16 minus C. Please don't say 4 minus 4 is 0. Because this one multiplies into the bracket. All right? So what do we have? Oops. What do we have? 4 minus, no, plus 64 now. Because negative 4 times negative 16. Plus 4c equals to what? 0. What is this? 68, right? Plus 4c. 4c equals to what? Negative 68. What is c? 17. Negative 17. Oh, we're done. The equation already. Because it was c that was disturbed. Right? So what do we have? Equation of the tangent. Y equals to. Done. This is what a grade 11 learner will do. Is that okay? Now, what will a grade 12 learner do? A grade 12 learner will bring in calculus. But we must know. So for grade 11 perspective, you must know that at the point of intersection, the roots are equal. Because in grade 11, we don't do calculus. Now, let's use calculus to solve this. Using calculus. What do we know? The first derivative is equal to what? Gradient. Big 5. If you remember, I taught you about the big 5. What is our f of x? X squared minus 16. Can we derive? F prime of x will be equal to what? Remember, deriving a constant is 0. But do we know the gradient? remember we said those lines are parallel. So what do we have? 2x equals to negative 2. What is the value of x? Negative 1. But we need the y value. How do we get the y value? We substitute in the original function. What are we going to have? Y would be what? Negative 1 squared minus what? 16. What is that? Negative what? 15. Somebody's saying, let's see if we are going to get this 17. All right? But now we know the equation of a line. What is it? Y equals to what? Mx plus c. Do we know our y value? Negative 15. Do we know our gradient? Negative 2. Do we know our x? Negative 1. What do we have? Negative 15 equals to 2 plus c. Move that there. What is c? Still the same thing. All right? Negative 2x minus what? 17. And you can also, like Baby says, y minus y1 equals to what? M x minus x1. Y, what's our y value? Negative 15. Negative 2. What's our x value? Negative 1, right? So y plus 15 equals to negative 2x, because it's plus there in the bracket, multiplied by negative. Take that over. Check. So you've got to choose a particular, but I'll say no both, but then walk through. Okay, I'm seeing a whole lot of things. Yes, we can use, okay, yes, test me a calculus. Arithmetic, what's your question? I'm done for the day though, so that we are fresh again when we look at what I will advise. Once I upload this, guys, please go over it. It brings all your concept from question 1. Right? From question 1. I hope we still remember our inequalities though, where we use what? Critical values. So it brings everything from question number 1. Let me see. And we stopped at the first part of functions. Remember how we did this? I don't think I recorded this, but remember how we solved all of this. Very, very important that we go through and solve. We use our critical values and our number line to get all of that. Please, very, very crucial. We started from here. These ones are walk in the parks. Okay? We get to inequalities. We get to laws of exponents, simultaneous equation, and then we started from here today. I think we did good work. We did good today. If you can go through these lessons again to remind yourself of the concept. So please find time. Just go through it in bits, bits. When we now come back, what are we looking at? We're looking at the other side of functions where we are fresher now. What are we looking at? Inverse functions. Then we go to financial maths. Then we hit calculus again and run through the rest of the paper. Then meet again to finalize wherever issues are. We write our paper 1, we get 120 minimum and hit it. I don't know if there's any question. Are we all good? I'm done. I am done. If there is no question, good night, everybody. But if there is, you know what to do.